Hello everyone and welcome back. My name is Mr. Kovalt, and in this video we're going to go over an example of using the Henderson-Hasslebach equation for a simple acid buffer solution. So let's get into this. So here's the question. We have a solution. It's made such that it is 0.4 molar acetic acid and 0.5 molar sodium acetate. What is the pH of the resulting solution? So when you are given a problem and you're considering using the Henderson-Hasslebach equation, there's a few things you need to look at, or at least a couple things you need to verify before you just jump into using the Henderson-Hasslebach equation. And here they are on the board. So one, double check to make sure it is indeed a buffer system. So if we look here, we have 0.4 molar acetic acid and we have 0.5 molar sodium acetate. The acetate ion is the conjugate base of the weak acid that is acetic acid. So we have both the acid and the conjugate base present, and they're in fairly high concentrations, 0.4 and 0.5 molar each. There's no dilution corrections in this problem necessary. It's not like we need to there's no dilution going on here, so we can use the given molarity straight off. And sodium is a neutral ion, so we can ignore that. So the only two things that we have in solution that are important for the buffer is the acetic acid and the acetate ion, and we have a fairly large concentration of both. So it's a good buffer. So the second thing we want to look at is the Ka value of the weak acid. And if you look up the Ka value for acetic acid, you'll see that it's 1.8 times 10 to the negative 5. That is a fairly small Ka value, especially when you compare it to the concentrations of the acid and its conjugate base. It's on the order a magnitude of about 10,000. Factor of 10,000 difference between the initial concentrations and the Ka value. So we can suspect that X is going to be negligible. That is the change in the amounts of things based on the shift. And so therefore we can assume that the initial concentrations of our substances will be equal to the final concentration. So therefore, the factors or the conditions are met so that we can use the Henderson-Hasslebach equation. And so, as a reminder, the Henderson-Hasslebach equation is the pH is equal to the pKa plus the log of the base over the acid. So if we plug everything in, so we find that the pH is equal to the pKa, and the pKa is equal, we'll just plug that in. So the pKa is the negative log of the Ka, which is 1.8 times 10 to the negative 5. So we'll just write that in, 1.8 times 10 to the negative 5. And then we have plus the log of the concentration of the base, which is 0.5 molar. So we'll put in 0.5 molar over the concentration of the acid, which is 0.4 molar. So 0.4 molar here. And then when we calculate this out, we get 4.84 for the pH. If we calculate the pKa comes out to 4.74. So if we calculate that out, pKa for the acetic acid, so the negative log of 1.8 times 10 to the negative 5, actually comes out to 4.84. Let me double check that. Or I'm sorry, 4.74. 4.74. And so what you'll notice is you'll see that the calculation of the pH that we came up with is greater than the pKa, and that makes sense because look at the ratio of the base to the acid, the conjugate base to the acid. We have more conjugate base than the acid, so that gives us a number greater than 1. If you take the log of that, you're going to end up getting a greater number for the pH. Your pH is going to be higher than the pKa. If it was flipped, if we had a lower number for, if we had a higher number for the acid and a lower number from the base, then because we have more acid, that would bring down the pH, and so you would expect to have a pH lower than the pKa. What happens when you get a pH equal to, what happens when the ratio is equal? So if you get an equal number of the equal concentrations of acid and base, then this becomes 1, the log of 1 is 0, and then you get pH is equal to pKa. And so just wanted to point that out. Just make sure that you can identify that your pH makes sense. In this case it does, because we have a higher concentration of the base, which means that we should have a higher pH compared to the pKa. Okay, so that's it for this video. In my next video, we'll use the Henderson-Hasslebach equation to go over a simple buffer, base buffer. So that's it for this video. If you like this video, if you enjoyed this video, if you learned from this video, then please by all means hit the like button, share the video. Also, don't forget to subscribe to my channel, hit that notification bell up there, and then when you do, click all so you can be notified by all the videos I put out. And finally, put a comment down below in this comment section. Let me know what you think, ask me questions. I would love to hear from you. Thanks for joining me. Have a great day.